So in class chapter number 23, I've already started the vector after finishing the problem solving on kinematics. So in vector, I've already started the chapter name. You can better to use some other color. This is vector. The vector part that I have told you in the last chapter, that is the vector, the remaining part, which is tells about the vector addition. Specifically, I have started vector addition. Okay, in that I have explained already the triangular law of addition, the triangle law of addition, triangle or triangle law of addition. I have already explained in that if a triangle, two vectors are represented by in order, then the closing side of that triangle on the opposite order or the reverse order will denote the resultant of these two vectors, that is represented by the two arms of the triangle. Okay, this is one. Or if three vectors are acting from a point in such a way that the sum of the three vectors a, b, c, let's say, if sum of the three vectors a, b and c, sum of the three vectors is 0, then it will represent the three arm of a triangle taken in same order. So that would be represented by the arm of the triangle which is taken in same order. So this is the triangular law. Now next come to the polygon law of polygon or vector addition polygon law. You can say vector addition polygon law. Addition polygon. Okay, polygon law. So it is of same kind of a triangle. In triangle, what is said? So it is only the number of vectors increase. So what we will say, if number of vector represented by the arms of a polygon in magnitude and direction in order, then the closing side, or you can say the remaining side, in reverse order will represent the resultant in magnitude and direction. Okay, so it is the same way that triangular law is being described. So the first part of that says, if a polygon is there, let's say I have taken a polygon, is a pentagon, let's say, there are vectors a, b, c, d taken in order. Let's say I am taken in order of anticlockwise. All these vectors a, b, c, d is represented by the arms of the polygons in magnitude and direction. Then the closing side, that means the remaining side which is closing the pentagon, will taken in the reverse order, will represent the resultant of these vectors. Okay, so this will be the resultant R, and R will be the A plus B plus C plus D, all these vectors taken in reverse order. So this is nothing but the same repetition of the triangular law but in extended form. Here in triangle the limitation is the 3 arm, in polygon that could be more than 3 side of the any pentagon, you can say, any polygon, you can say, that could be, that will fall under this as a polygon. Okay, where number of side is more than 3. Okay, so then that is considered to be coming under this. But and the second part of is of similar, that says if multiple vectors acting from a point in such a way that say A, B, C, D, E, A, B, C, D, E acting on a point, if number of vectors acting on a point such that the sum of all vectors are sum of all vectors is 0. So here you have to say in the number of vectors acting on a point such that the sum of all vectors is 0, then the vectors are represented by the arm of a polygon in magnitude and direction taken in order. So that is the same repetition of the triangle, but that in this case it is taken as a polygon. So it means that if I explain it, the second part of the first part already explained, second part of it if I explain, so A, B, C, D, E. So that means if these 5 vectors A, B, C, D, E, if 5 vectors acting on a point and the resultant of all these 5 vectors is 0, A plus B plus C plus D plus E equal to 0, then it will be represented by the side of a polygon taken in order. So all has to be in same direction. So then only we can say, if this condition implies that all the sum of all the vectors is 0, then it will also can be represented with a polygon having a number of vectors here. The polygon has to be of same number of side, and then these vectors can be represented with the magnitude and direction taken in same order, taken in order, you can say. So this is the case. Now if polygon is the sum of triangular law, how can I prove that? If I take the first condition of that, if I say, now I am considering the first condition where I had said I have said that the polygon, let's say this is having 5 arm A, B, C, D taken in order, C, D taken in order, then what is the resultant of it? Now if I go one by one, if I close this triangle, okay, divide this triangle, now A plus B is equal to this one, so I can say A plus B. So then A plus B plus C, this is in the same order because this is clockwise, this is anti-clockwise. Now this, if I consider this triangle, this is plus, this is clockwise, then resultant will be A plus B plus C. Okay, now this plus this, what would be the direction of it? It will be of this direction, because clockwise, anti-clockwise. So this, what will be this? A plus b plus c plus d. Okay, now it proves from the triangular law I can prove the polygon law. So polygon also satisfy the triangular law, and if triangular law is correct, then polygon law also to be correct. So that I can prove it. And if I want to prove the second part, A, B, C, D and E. Now as per the triangular law, this plus this to be this, so A plus B, this plus this to be this, A plus B plus C, this plus this and this. Or triangular law, if three sides represents a vectors which taken in same order, then you can say A plus B plus C plus D plus E, because three vectors taken in same order and enclosing triangle, so it must be 0. So this proves the first part of the law of addition for polygons. So you can say once the triangular law can be said to be true, then polygon law has to be can be proved. So this is way I can prove the polygon law also. So now come next the law of addition, parallelogram law. So the third part is parallelogram law of addition. Okay, so now in this is simply parallelogram. We know if the opposite sides are parallel and equal to each other. Now it says if a parallelogram, the adjacent side of a parallelogram represent two vectors A and B, okay, then their diagonal will represent the resultant of it. So this is parallelogram law. If the adjacent sides of a parallelogram taken from a point, means I am representing these vectors taken from a point, two vectors taken from a point, then its diagonal from same point will represent its resultant, their resultant, not its, their resultant. Okay, so this is the rule. So that means R vector will represent A vector plus B vector. Okay, so this is the parallelogram law. So now this can also be proven from a triangular law, because vectors parallelly you can shift if magnitude and direction, that won't change. So B vector, if it is represented by this, so this other side which is of equal length of a parallelogram can be shifted. So I can say that this is B. Now you apply the triangular law, A vector and B vector taken in order, R will be the resultant taken in opposite order. See, this is the nothing but the triangular law. So all are interconnected. Once triangular law is can be said okay or correct, then all other law are related and can be proven with the help of triangular law. Okay. So now come the mathematical part of it. What is that? What is the relation between the resultant and the vectors? So that I will derive from a parallelogram. So let me draw it again. This is the parallelogram. This is A vector. This is vector A. This is vector B. This is resultant R. This angle is theta. This angle assumed to be alpha. Now I will drop a perpendicular on the extension of this vector. So I will name the point A, OA, B, C, D, let's say. Okay, so now I have to establish some relation. Now from this you can say if this line parallel to this and this is the intersecting line, this angle also to be theta as per the geometry, you know. If two parallel lines intersected by the line, so these are similar angles, that should be equal. So from that we can say that this would be theta. So from that triangle, this also the parallel vector A, so I can say this is A and this is also B. If it is needed, we will use it, but for the identification we can say that the parallel vector in magnitude and direction would be of same. So from here what I can see, what I can write, if I take the cos of theta is this angle, this is nothing but cos means base by this hypotenuse, base is DC upon dV. So cos theta is equal to DC means how much? DC is this much. So DC, I'm just for the sake of writing, I'm taking this x and this is y. So I'm taking this is x by dB is equal to A. So x is equal to how much? A cos theta. Okay. Now if I take the sine of it, sine theta, that will give you this BC height upon hypotenuse, this is dV. The same I have taken it is y by A. So y is equal to what? A sine theta. So these are known. Okay. Now moving to this triangle. If I take this triangle, this is perpendicular, so this is 90 degree. Okay. So this is 90 degree means this is the diagonal of 90 degree. This means hypotenuse of the 90 degree. This is vertical and this is the horizontal. So from this I can say OB square is equal to OC square as per Pythagoras law. Pythagoras formula you can say BC square. That means hypotenuse square is equal to base square plus height square. Now OC can be written as the known variables, that is OD I know. So with that whatever the variable taken, this is x. So OC can be written as the vector V plus x whole square plus BC is what? Y you have taken already, y square. And what is OB? The resultant square. Okay. Now this part I am writing somewhere on the top because that will be useful later. What is that? X is equal to A cos theta and y is equal to A sin theta. Okay, now I am rubbing it up. Okay, now what is this? If I expand it, B is equal to B square plus 2 into B into X plus X square plus Y square. Okay, so B square is B square, 2B, what is X? X is equal to A cos theta plus, if I take X square and Y square in bracket, let me see if anything I can write. Now X plus Y square, X is for this triangle, what is X? This one, this is height, this is base, this is again a right angle triangle, this is the hypotenuse for this case. What is X square or Y square then? For this triangle, right angle triangle, X square plus Y square would be A square. So I can put it there, A square. So in this next equation, next line, I can write A square, I will bring it here, plus 2, keeping in order, 2x cos theta. So this is nothing but R square. R square. This is all I am calculating the value of that magnitude. I am not taking any direction right now. So I am just considering, as we know, that resultant is a combination of the vector this and this. This resultant vector of this and this. From there, I am putting some mathematical relation. I am not considering the direction right now. So these all are perfectly the magnitude I am looking after. Okay, but mathematically you can say, because I have shown that resultant is, what is that, for the triangular B vector plus A vector. Okay, but V vector, A vector are acting upon some angle theta, because if I extend it, it will extend, and this is the vectorial representation. What is the magnitude of that? This will be somewhere, this will be represented by what it has been represented or how it is being related, that I am deriving with the help of this right angle triangle. It's not that I am directly writing the r square is, because r square it is representing in this triangle. So I am establishing some relation. Okay, but vectorially this is the, and if I take the mod, so this will represent the magnitude. But what is the magnitude? Because B and A are not even collinear, but it's not acting in a same line, either in the same direction or in the opposite direction. Then basically it is not as algebraic sum. But how it is related, to establish that, I am establishing the magnitude of that. So from for that I am deriving some formula. Okay, don't confuse with the vectorial summation. This is actually vectorial summation, but there has two things. One is magnitude, one is direction. I cannot go with both together. Rather, I will establish the magnitude, then after I will establish the direction. Okay, that is only possible if I can divide the vectors into x and y and x direction, and then add it up, then sum it up. So that will be a different process altogether. But here I am separately establishing the magnitude, and then after I will establish the direction. So that will, one shot will give the value of the resultant. Understand? What I have shown you, that is I am dividing in x direction, y direction, if it is a Cartesian in z direction, then after x direction was the components, y direction was components, and z direction was all together, that will come under root of x square y square plus z square, or otherwise if it is two direction, x square plus y square. Okay, so that will come once I will divide this into component of x and y. But here I am not doing that. I am just considering the other way, following this rule, how to add vectors, that is a vectors with a unit vectors that I have shown. Here I am showing you with the parallelogram law, or it in conversion with the triangular and polygonal law. So this is totally different, but if you do that also, the result will come same. Okay, so this is other process of doing. So here the resultant r, this means I need not to write r because is already I am doing the numericals. So r is nothing but a square plus b square plus 2ab cos theta. So that means if two vectors are represented with the parallelogram, the sides of the parallelogram taking from a single point, so the result will be the same from the same point if I draw the diagonals. So, and what is the magnitude of the resultant? It will be under root of a square plus b square plus 2ab cos theta, the angle between the two vectors. So this will the magnitude of the resultant. So this can be also written as this way. Okay, now this is the only magnitude. So what would be the angle? So for that I assume this angle, because this you can assume is a horizontal, that means equivalent to x-axis this. So I am not just dividing the component x and y direction. So this, if I follow, that will be a different method altogether. But as always, the resultant will make angle with the positive x-axis, although this is always a horizontal line. So I can assume it is x-axis. So there with the horizontal component, I am just taking an angle. Or it may happen, it's not that a horizontal always will get, that vectors may be of any angle with the horizontal. In that case also I will take the angle with the base vectors, not that with the horizontal. If it is not specifically told, that you just calculate the angle with the horizontal x-axis, unless and until it is told you have to take the angle with the vectors which is just at the base. Okay, so the angle with reference to the base vectors. So this angle is reference to the b vector which is in base. Okay, so what is the angle then? So you have understood the magnitude. Now I will come to the angle part. So for angle also, if, because I know the slope of any vectors is tan of alpha, that will give you the slope. So that is equal to this BC overall by what? This BC by OC, isn't it? This OC, this vertical by horizontal. So what is BC? BC is your y, and OC is equal to OD plus DC. OD plus DC. So y is equal to what? Already I have taken y is equal to, if I take the sine of this, y by a sine theta, that I have already calculated, is y sine theta, x is equal to a cos theta. So I will use it here also. Y is equal to a sine theta and OD is equal to b and DC is equal to x. So x is equal to a cos theta. Okay, so that is equal to tan alpha. In our language, alpha can be written as, if you go on a higher class, a inverse sign is there. That means it represents the angle, and it is the inverse value. That means it would come in some angle, angular value, means angle value, that will be represented if I calculate the inside, and accordingly from the chart, if I get a closer value, that may happen that it is not giving a perfect value of angle, it may be closer value, or sometimes it is a perfect value. So but ultimately the angle I will represent with alpha is equal to tan inverse. It's called tan inverse of this. Okay, so this is the angle which you will make with the vector b. Okay, so this is the parallelogram, the derivation of the magnitude and the direction of the vectors, resultant vector with the base vector of any of these vectors. Means if we assume this is alpha, so then accordingly the alpha will be calculated. Okay, so this is the end of parallelogram, the vector addition laws. And in some cases there may be possible, so I can if now resultant is what, I already have formula, under root of a square plus b square plus 2ab cos theta. Now if you are aware of the value of cos theta, the cos theta may vary between +1 to -1. Okay, and in this varies from minus, this varies from you can say cos minus 90 cos theta to 90. This way the value varies. Okay, so there are some other relation, but as of now, if I assume that cos theta, I am directly putting this value. If cos theta is equal to 1, let's say, for some value of theta, so what would be its value? Resultant. Because you don't know all this trigonometric value, only thing you might have learned the first coordinate system, where up to 0 to 90 the values are known, sin theta, cos theta and tan theta, and reverse of that you can automatically calculate. So so this value you know, So if I say that cos theta is equal to 1, so where that cos theta is equal to 1? For theta is equal to 0 degree. That is a standard table is there. For theta is equal to 0 degree, cos theta is equal to 1. So that means resultant will be, if cos theta is equal to 1, that will turn into a square plus b square plus 2ab, and cos theta is equal to 1. So that will turn into a plus b. So now see, resultant, if where it is a plus b, the sum of this, practically you have already learned that if two vectors are acting in the same direction, so then their values has to be added. So this is the case where, so this also be the same, because theta means what? So this vector is acting in some angle AB. Now this is theta. Now slowly this theta becomes 0. So it will be collinear and the direction will be the same direction. So this is the case where theta is equal to 0, and it implies that a plus b. So this also satisfies that the formula is okay, right? This is one case. Now if I take cos theta is equal to 0, so cos theta is 0 where theta is equal to 90 degree. So cos theta is equal to 0. If I take 0, so resultant is, the value of the magnitude will be a square plus b square, because cos theta is 0 means this term will be become 0. So that means it is equal to, where it is possible. Now two vectors, let's say I am taking the same example a and b, where this is theta. So 90 cos theta is equal to 21, theta is equal to 90, that means this is vertical. So these vectors become vertical to each other. We know that vertical vectors, the result is what is a square plus, because this is 90 degree, so this will be become a square plus b square is equal to the resultant square. Okay, so this is the case where, in case theta is equal to cos theta is equal to minus 1. So what is the case where this cos theta will be minus 1? If theta is equal to minus 180, or sorry, is 180. So what is the formula? Cos 180 is, because we know in the coordinate system here all is positive, all sine, tan and cos. But the conversion happens when something goes in multiple, means in a even multiple of 90, then after some theta, so any thing will change to the next, what can say, the companion companion ratios. That means these cos and sine are the ratios. So that companion ratios are cos turned into sine here. Okay, that chapter I will come later, because that needs to understand some basics, so that you will not able to understand. But as of now you understand that cos 180 is equal to turn into one, that assumed to be 180 means it can be assumed that 180 minus theta, 180 plus theta. So 180 minus theta, that means this will be turned into, I cannot assume that 180 plus theta or minus, because it will turn into 0. So better if I write it 90 plus 90. So something in even order, that will that will change cos into sine. So that will become, and as because this is 90 plus 90, that means I can assume it is in a second coordinate. So cos turned into 90, so sine 90. Okay, so sorry, that cos 2 into 90, that means that will come to cos into minus of cos 0, that comes into cos 180, that comes cos minus of 0, means cos, if it is in second coordinate, cos 2 into 90 multiple of anything, that will remain as cos, and the angle, as because it is here in second and third coordinate, whatever wherever it is go, because cos if it come to there, if I assume that 180 plus 0 or 180 minus 0, that anyhow it will bring to these coordinates. Okay, now in those coordinates cos is assumed to be negative. So as it is 2 into 90, so it will not change this cos, and as because in the second or third coordinate cos is negative, so cos will 180 will turn into cos 0, and cos 0 value is 1 minus, so it will all together it will come to minus 1. So that means theta is equal to 180 degree. So what is the case where theta is equal to 180 degree? It will turn into under root a square plus b square minus 2 into ab. This cos theta will be minus, so that will change the sign. So ultimately that will be a minus b. Okay, this depends on the value of a. If a greater than b, I can assume this is positive. So what is that? If a and b from a point acting in the opposite direction, this is a, this is b, so I can say that a minus b is the resultant. So this implies that if theta is 90 means 180, so if theta is acting between these two axis, if it is turned opposite side, so that will make 180 degree. So that again the resultant a minus b. So that is also already learned, but with the use of this theorem also that can be proven that that is correct. Okay, so these are the cases. Now another case, this is the cases where the specific value of resultant will get. But what if tan alpha is equal to, I have said already, a sin theta divided by b plus a cos theta. So in case of theta, if I take 0, so what is the value of tan alpha? Theta is 0 means sin theta is equal to 0. So ultimately this is 0. So tan alpha is equal to 0 means alpha is equal to 0. So that means if I take this vectors a and b, if they are merging together, so then the resultant, whatever angle you say, that also merge together. So alpha will be 0. So that means theta, if it is in collinear, then resultant also to be in the same line. So that implies that theta must be 0. Okay, understood. So this is the case. Now if theta is equal to 90, so the value of sin 90 is 1, sin theta sin 90 is equal to 1, and cos 90 is equal to 0. So what is the value I will get here? So a upon, this is 1 and this will be 0, a upon b. Okay, so that means if the vectors are acting 90 degree to each other, theta is equal to 90, so resultant will be at ratio of, this is then a, because this is parallel vector, this is a, this is b, so this is nothing but theta alpha. So alpha will be the tan inverse of a upon b, that I can calculate a upon b, because this is alpha, height upon base, so this is implies the same. So this is the value. And if a and b are equal, then alpha is equal to tan inverse 1, because a and b is equal to 1. Tan inverse 1 means 45 degree. So alpha become 45 degree if a and b are equal in this formula. Okay, if a and b are equal. The case where theta, if it is 180, so sin 180 will become sin 0, that means 0. So again the tan alpha is equal to 0. So if in case this is acting in the opposite direction, the theta is equal to 0, the resultant will act towards either of the bigger, because if a is high and b is less, though the resultant will be along the a minus b, or if it is b high, then resultant will be b minus a, but the alpha will be collinear with the any of the vector. So alpha will be, as per this, is equal to 0. Alpha will be the vector, so that the resultant I can, even if a is less, that vector I can say it is towards the, because this I have taken positive, so if result is negative, so it will be this direction, but ultimately the vector will be 0 degree with the vector. Okay, 0 degree, or you can say 180 degree, because if it is a is higher, so the vector will be this direction, so with the base angle alpha will be 0. If it is b is higher, so vector will be in opposite direction, so with the base vector it will make 180. So both cases is possible for tan alpha is equal to 0. So because tan 180 is what? Tan 180 is again tan 0, and tan 0 lies between this 180 plus 0 you can consider. So this is the just in the line. So in that case it is an advantage to take 180 is equal to tan 0 and tan 0 is equal to 0. Okay, so 180 also will become value is 0. So in that case, if it is in same direction, this is alpha is equal to 0, in the opposite direction is 180. So these are the specific case where this could be varied. Okay. Any other case possible? If I take this, is it possible that alpha is equal to theta? Is it possible? If I say alpha is equal to theta and A is equal to B, then what is the condition? If I say A plus A cos alpha, that means sin alpha will be a specific case when it will be cos alpha, A will be considered, that will be tan alpha. But if it is the case, then if I divide it with the cos alpha, that will be the cos, it will be sec alpha plus tan alpha, cot alpha. It will go somewhere else, it will not establish some relation, but it will be somewhere else. So that may not be possible. If I go and calculating the condition, this is not specifically described anywhere, but I am considering if in case it is possible. But anyhow, if the two vectors are distinct, there cannot be possibility this angle and the resultant will be same. It can be only possible if resultant is equal to A, then only this will lie in one line. So this is the only condition if theta is equal to alpha can be possible, I suppose. Okay, in that case they will lie on the same axis and that theta and alpha will be same. Okay, so this is not the specific case. You can try it home if it can be possible. So this is the end of the vector addition, and we will move on to their some problem solving in the next class. Thank you.